Good morning, everyone. So now, for today's lecture, we have Professor Santosh Kumar Das sir from NIT Rourkela. Okay, so he'll be taking on the practical aspects of IoT, smart city, and applications. Because we have learned all about this robotic IoT in this journey of 7 days. Today's 6th day. Okay, so now in this 6th day, he'll be explaining all the things about the practical assessment, practical aspects. That is all about what a workshop is. No. If you don't know what to do at the end of the day with a practical exposure, we can't move forward. So I think this will be much best, will be better presentation and the lecture. Please enjoy it. Okay. So please give a round of applause for
Good morning, everyone. I'm Professor Das from NIT Rourkela. I heard that in the last few days there were lots of officers and industrial experts. They delivered lectures related to IoT, right? So I don't want to go through the IoT theory part in details because everyone knows what is IoT now, right? So I'll be these slides, whatever I'm presenting now. This is related to some theory part. And today's talk I have organized in different way. First, my plan was to explain about what is IoT theory part, what are the applications. Then second part is related to practical implementation of one case study. Okay, and the third one is hands-on experience on practical implementation. These three parts I have organized, and I'm planning to give 30 minutes each for each part. So, from the beginning, I just want to say, uh, so whatever I'm going to present, this is related to a product. You can see this is a product. Okay, so this is a product, and this can be used by any vehicle driver. This will be mounted at vehicle car. Okay. So you might have heard about tracker, vehicle tracker, right? It is a similar kind of applications, but with different features. So we have added many features, and I am going to explain how we have developed this product. What are the challenges? So what are the things we have done, and what are the next step to do for commercialization? This is not yet commercialized. Now it is on prototype models, and also there are two patents already we filed based on these products. So this is a purely practical aspects, and you can say it is application of IoT on different applications. So I will explain what are the applications, what are the features in later. Before that, I am just going to overview what is IoT. Okay. So now you can see in this product, see one device. What is? Anyone guess what it is? GPS. This is GPS. It is connected to the board. So inside board, there are many things are there. Inside board, you can see there are many things. There is a microcontroller, then GPS, then sensor board. All are integrated and fabricated. So I will explain one by one what are those components later. And by the way, he is Mr. Harshit Ranjan. He is doing PhD under me, and he is working on development of pollution measurement and broadcasting of uh, pollution levels. Okay. So he's going to submit very soon. So now this is just overview. You can see. Uh, I just wanted to say something. What is IoT? Under this, what are the challenges? What is the Industry 4.0? What are the disruptions in IoT? What are the architecture used in IoT? What are the block diagrams? And what are the built-in IoT applications? Then potential of IoT. Under this first slide. Second, then I just want to say few things about sensors and things. Then third one is application of IoT. What are the applications can be developed with using this IoT? And last one is clusters. Now this is you can from this figure you can say what is IoT. Okay. Everyone knows right in last 4 5 days you might have known what is what is the definition of IoT. IoT means any device, any things you can connect to internet. That's the definition of IoT. And once you connect to the device, then why you are connecting to the internet? There might be some application, right? So that application, how do you develop? Okay. How do you connect device? After connection, how do you use that device for different applications? These are different parts of IoT, different components you can say. It includes microcontroller, database, then mobile app, backend applications, many things it contains. So you can see how it works like you can use mobile devices. You can control any device, whichever is connected to internet. And there are different facility features are there. These are features of IoT. The basic objective of IoT is you can use any IoT device, anywhere, any location, and anytime. That's the purpose of IoT. You can see the timeline of IoT, how it started, and what is the current status. Now you can see everywhere people are using IoT device. So everyone want to connect their devices to internet. Even for example, in my house, I just want to control all the bulbs, fans, the fridge, everything I want to control from my mobile. So I want to connect everything, whatever available in my house. So that is called IoT. That's why the day by day, the growth of IoT is increasing. Okay. And accordingly, you can say number of users. In 2002, this is one of the survey. That 50 billion devices were connected in 2002. Now it might have increased. These are the technology stacks. You can see technology stacks means like it's similar like OSI 7 layer, starting from hardware devices to applications. And potential of IoT, why people use IoT? Only because of to reduce time, to save time, and also to save money. So there are few examples like how those industries like aviation, power, healthcare, rail, and oil and gas, how they use IoT technology just to save money and just to save time. Challenges, there are lots of challenges in IoT because IoT means it's a tiny devices. Okay. The lots of challenges like I have categorized in different uh, forms like system designing, data management, then device management, service management, security. These are different type of challenges. In every modules you can see, or suppose for example system design, you can see there is a centralization issue. There is lightweight. You need lightweight devices. Okay, because you don't need bulky. Now that device I show you right. Initially, when I started, that whatever we developed, that was very bulky because that one was having battery and also that one initially we used Arduino Uno. That one is bit bulky. Okay, and also we used different. USB connector. So that time it was this much of size. I mean, it is around 12 inch size. But now, after lots of research, that is the final one. Again, we are planning to make it small size, lightweight. So that is one of the issue. Because nowadays people are talking about nanotechnology, right? So using nanotechnology, you can make it smaller size. For example, mobile device. So mobile device, whatever components they use, those are nanotechnology, application of nanotechnology. Right? Why in India mobiles are not developed? We don't have that kind of technology available in India. But slowly it will be coming up. Now people are doing research on nanotechnology. How they will be making chips design. Government is providing lots of funding for chip designing. So once it is okay, once we'll able to develop chip design, then we can work on nanotechnology. So that time we'll be able to manufacture mobiles because in mobile device we need very small sensor like for weather monitoring. Okay, for any kind of sensor like fingerprint. In mobile everyone you can see the fingerprint, small fingerprint. You might have seen fingerprint in bank side, bigger size that you cannot mount in mobile, right? It needs smaller devices. So that is one of the issues. Lightweight. Another one is performance. Performance is a major issue in IoT devices because you need high speed data transmission. Like suppose you want to stream camera data, right? Or any kind of suppose this is now they are streaming our lecture. So how you make it? How you make it better performance? Like because these are smaller devices. IoT means it is smaller devices. How to make it faster with better efficiency and performance? Those are also challenges. Because video processing you cannot do in normal type of Arduino board. You need high-end processor like NVIDIA board. Okay. So, but again, it depends on the processor. Then only you can design that. Those are the different challenges on the system design. Then data management. Data management is another issue. It is something like because sensor means it's a huge data, right? For suppose you want to measure temperature of this room per minute, how many instances you are collecting data. So you need to store those information in database. So that much of storage you need also need, right? So that is one of the challenges in data management. Processing. Suppose you have a last 10 years of data or 20 years of data, how do you process those data? That is also one of the challenges. Data management, data processing, data storage, then data mining also. Just now I mentioned about 50 millions of IoT devices already been connected in 2020, right? Now, how do you mine those data? Suppose I want to mine one sensor out of 50 million sensors. How do you mine? That is a challenge. It will be very difficult, right? Device management. Device management also is another challenge. Like how to deploy sensors, how to deploy IoT devices. Like for example, suppose uh, this one device I already developed, right? I want to deploy it inside a car. Okay. Now because lots of air and we have seen car right inside car, there is no space to deploy that one. I have to find a space, the better space, the safe place where I can deploy that device because that device is related to accident detection. Once accident happen means the car will have different shape, right? And this device also will have different shape after accident. So how do I deploy that device inside a car so that this device will be in a safer space? Just like black box in aeroplane. Those are different kind of devices. If anything happen in suppose plane crash or something happen, the black box will be set, always set. That gives lots of information. So I'm thinking about this device as a black box for a car. Okay, so deployment is one issue. Then device maintenance is another issue. Okay, suppose for example, you develop some product which will be deployed in forest, right? In forest, uh, it will very inaccessible, right? You cannot go to forest every time. If something happened to that device, how you maintain that device? That is also another challenge. Then service management. Under service management also there is service discovery, service payment. That is also another issue because there are huge number of devices are connected to internet. But very difficult to discover the devices and also repair the service. That is one challenge. And security is another aspect. Now people are talking about cyber attack. Many things are there, right? And this is mostly the researchers are focusing on security aspects now. Network security. How to make a device there. So these are challenges. Compared with hardware devices, we need to electrical hardware and security, then authentication, communication, and privacy. These are different type of security. Now coming to industry 4.0, it is nothing but the IoT itself. It is called industry 4.0. It's the fourth generation. IoT is the fourth generation uh, uh, the technology. Uh, that related to cyber physical system, IoT. So that is nothing but industry 4.0. So nothing to explain about that. What is fourth generation? Everyone knows about this. So these are also same thing. Then vision and implication. Everyone knows what is the application of IoT or industrial 4.0. Basically, you need to control everything from your fingerprint, right? That is the fingerprint. That is the objective, main objective. How do you do that? That depends on you. This is also uh, the same thing. No, to explain. And and this is the basic flow chart of industrial automation, application of IoT, or you can see industrial 4.0. Uh, from your fingerprint, you have to control the machine side. You don't need to go to the field. You don't need to go to the field and manually control the switches. And so from control room itself, you can switch on, switch off. We can control the machine speed. We can control the temperature. Everything we can control from the control room. Even from mobile also we can control. So same thing. And the disruption. Now coming to disruption. What is the disruption? What is the meaning of disruption? It is something related to the use of IoT technology. For example, we just think about uh, just one example, Netflix. Everyone might be using Netflix, watching movie, right? But Netflix does not have any theater, right? But how he is doing his business? He has developed something. He has developed some software, right? And he has he is able to connect the service providers like different databases. Then he is providing the services. Even he doesn't have any theater, but he is doing business and earning lots of money, billions of money, right? Same like Ola, Uber. They don't have their own car, but they are doing their business, right? Only because of the IoT application. They have developed one app. Using app, you can go anywhere by Ola or Uber. That is disruption. Yes. So people are using IoT and it's doing business and getting uh, uh, billions of dollars. There is also pros and cons, right? Pros, there are lots of advantages, uh, like uh, replace hardware physical work, like manual work. There is no manual work. You use IoT applications. Then before labor cost, when you use manual, when suppose you are controlling everything through mobile, you don't need any labor to go and manually switch on and switch off, right? Labor cost. Then automation is very easy. Cost is initially the deployment cost will be very high because you want to make everything automated. This NIT Jamshedpur. Then initial cost will be very high. Okay. But later on it will be cheaper. That is one of the cost. These are again IoT architecture, like it will have sensor, then there will be a data communication part, there will be a cloud service. This is the sensor IoT architecture. I think because what they might have explained about this, and this is you can say how the system works. The general generic type of IoT block diagram. Like there will be a device, this is a central device connected to any kind of microcontroller. Then it will be connected to internet, that is to cloud service, and there will be users. They could have some kind of app so that they can access those devices to internet. And these are the normal process, like there will be a sensor, processor, gateway, and application. This is very generic way of explaining the block diagram of IoT. Now, how do you build? This is also very important. I was talking about practical aspect of IoT, right? So the most important part is how do you implement. There are 7 steps are there. The first stage is proof of concept. Suppose you want to develop something, like what I have thought about accident detection. That is called accident detection. So my objective is accident detection. So how do I detect accident? That is the idea. Okay. So that concept you need to prove. Suppose I say if my car gets some accident, okay, then how may I detect that accident? What is the idea behind it? Using sensor. Okay. Then that concept I need to prove because many will have different kind of thinking. Like I can use sensor, human can use camera, right? So that two different ideas, right? But I have to prove sensor is better than camera for accident detection. Maybe sensor is cheaper, camera will be expensive, right? Or deployment of sensor will be easy, deployment of camera inside car will be not so easy and will be expensive. I can prove that way. So that idea needs to be proved. Once your idea is proved, prove means you can prove your idea, you can submit patents, like if it is an idea, innovative idea, then you can submit it as an patent. Okay. Once your idea is unique, then you can file patents. Okay. Then after that, you can think about implementation part. How do you implement your idea? So for any kind of idea, like organizing this event, they might have done for 5 days, 7 days workshop, right? They might have mentioned about some timeline. Day one, what to do. Day two, what to do. Day three, what to do. Who will be presenting in day one? Who will be presenting in day second day? These are some modular structures, right? So initially they might have prepared some block diagram. Who will be organizing? Who will be the convener, right? And how do you manage the transportation system for the export? So all these ideas they might have discussed in a team. That is called block diagram. Okay. Then after block diagram implementation, first meeting, right? Suppose someone is organizing something, they will be organizing one meeting, what need to be done, how to be done, something like that. Then after that, implement. How do you implement? Suppose I want to buy some export. I'll be sending email, sir, come here and present something. I'm sending my car, we come by car 2 hours late. These are implementation, right? It's not like I am sending. Already car is, they already sent the car to the airport to pick up. So that is called implementation. So that is That way you can say you have to think about how you implement. In electronics cases, like it will be like a block diagram. The block diagram will be converted to schematics. Schematics means it is something like you have a circuit diagram, electronic circuit diagram. Then you have to convert to what you can say. Let's convert to PCB board, right? PCB board. How do you make PCB board? We have to develop one Gerber file that using Eagle software. That software you have to feed to from PCB machines. So which will be giving you PCB board, right? So that is that. For that you need the schematics. Then bill of materials, like how many materials you have to produce. This is step 5. Then you speak about prototypes. So after PCB board, you can develop something like this. Uh, how you actually how you write device driver level programming, then how to access cloud there. That hardware development, software development. I will come to that later on. Then after that, after developing the prototype, you need to do the field testing, which is step number 6. Okay. This may take 3 to 6 months. Because once you have developed the prototype, you need to test it continuously, 24 hours. Okay. Like nowadays in academics, mostly in laboratory stages, they use very cheap kind of sensor. But same sensor is available in the market, so it can be commercial. You can use for commercial purpose. So maybe temperature sensor, the cost will be around 2 rupees only for laboratory level sensor. But for industrial sensor, that will be 50,000. Those are very expensive. So laboratory sensors and industrial grade sensors are different. Okay. So but if you are thinking about commercialization, you have to use commercialized sensors. So those sensors need to be tested in field, whether it is giving accurate data or not. Okay. So that is for field testing. Then after field testing, you can release beta version. Beta version is for people who can use your product. So they can, like, if you develop some application, we can publish it for article free license. So they can use this for 30 days, right? So within 30 days, they can email you. The email will say, you can sort out. Okay, so that's why beta version is very important. Then after beta version, after getting lots of feedback, again that product will need to be refined. So then after it is something like reviewing a paper, giving comments, then student has to compile everything, and then we will modify the article and will listen, right? Same thing after modification of everything, we got first production. Okay. Then after production, it will be released for final product, so that people can buy and eat. This is the mindset. Potential of IoT economy, which is already you know, and these are different type of sensors. You can say there are lots of sensors like temperature measurement, vibration measurement, sound measurements. Okay, humidity, then gas like different type of pollution, carbon dioxide, sulfur dioxide, and water flow. Different many kinds of sensors are there. Are just summarized here. And this is related to some kind of protocol like in any kind of microcontroller, Arduino, Atmel, or Azure Type 1, or like NVIDIA board, any kind of microcontroller, there are lots of things are there, right? In keys. So some of the things you can use as input pins, some of the things you can use for output pins, DPI. And how to access those pins? So for that also there is a protocol. Protocol means it's a set of rules. How do you access? Like suppose you want to connect internet. How do you connect to internet? There should be some rule, right? Protocol like the HTTP. You can use HTTP protocol. So in microcontroller also there are lots of protocols are there. Like one is ITC, inter integrated circuits. Using I2C protocol, you can connect to sensors, you can read information, then you can program it. That's called I2C. Okay. Then UART, Universal Asynchronous Receiver Transmitter. This is also very important because we need data transmission. There are different type of protocols are there for data transmission. One is RS-230. Okay. Then GPIO, that is another general purpose input output protocol. So there are different types of protocol. Those need to be SPI protocol. That is also there. So there are different type of protocols are there. Application protocols also there, like what I mentioned, how to connect internet. MQTT. MQTT is a message queue telemetric transport protocol. I'll come to that when I'll be coming to the case study. I'll tell how to use MQTT. Then COAP, constant application protocol. It is the special kind of web transfer protocols. Then another one is REST API. REST API is another protocol. Anyone heard about REST API? It is something like how do you access libraries? Like suppose there is a database, MySQL database, okay, or SQL database or Oracle database. The database contains lots of information, right? How do you access those database? So many companies they provide API, application interface. API through application interface you can access the database. That is called REST API. This is one of the protocol. I think it is provided by Google, right? REST API is provided by Google. Yeah. But many times what happens, these APIs are not free. Because you initially it will be free, then after 1 month they will asking for license. Okay. If you are a developer, you are developing products, uh, you should develop your own API. Yeah. Otherwise it will be very expensive. And then this is sensor interface layer. How do you interface the sensor? I think this is already, it might have already discussed. I'm just keeping. But you can see here, these are the protocols. GPIO, I2C, SPI, LDC, timer. These are protocols. How do you interface sensors and the timer? What should sensors do? Sensor? Sensor knows what. So normally these are the sensors are very low level device. Low level in terms of low level in terms of power. Power. High volt, 10 volt. So that's why it's called low level drive. Then another important thing is cloud data. So in IoT application, cloud is very important. Cloud means it's a server. Okay. It can be a local server, it can be a cloud server. Okay. And the cloud server can be third party like Amazon, Google, yeah, AWS, Google, I can many third party servers providers are there. And also you can have your own cloud. Like in Karyashala, we have our server, personal servers. We don't use Amazon or anything. We use our server. That is actually cloud, but that is not local. That is remote cloud. It's locally deployed, but it's a remote cloud. I'm using one of the database. I have purchased one server with around 10 lakhs. I kept that server in our computer center. Okay. That is my cloud. I'm using my own cloud. I'm not using any third party. And when you are using your own laptop or desktop, that is called local cloud. Okay. So local cloud and remote cloud are different. So this is also very important. And another important thing is connectivity. How do you connect devices or sensor or anything to internet? There are different type of technologies. Depending on data rate also you can choose the connectivity type. High data rate, then low data rate, and then what is that low energy consumption, wide area coverage. Depending on your application, you can choose your connectivity. Okay. Suppose for example, you just need to transfer the camera picture to your friend. What kind of connectivity you want? Bluetooth, right? That is called what's called low energy consumption level. Only Bluetooth we can use for long range transmission. Suppose someone is sitting 10 kilometers ahead from you. So what kind of connectivity you want to transport data from your system to his system? You can use LoRa, right? 10 kilometers. LoRa you can use, NB-IoT you can use. These are the things, LPWA. And again for long distance one, that is you can use 3G, 2G, 4G, 5G, whatever, right? So depending on your application, you can choose your connectivity. Okay. Something I already mentioned about it. Depending on your requirements, you can choose your connectivity. And these are related to data routing. How do you transmit data from one device to another? Yes. That is the timeless things on is answer. Then same thing. Like in data networks, there are different type of networks. Like wired, wireless. Wired means like so Ethernet you can transmit data. Ethernet. Connect, right connect. Wireless means like you can use free space optics. You can use Wi-Fi. You can use Bluetooth. You can use Wi-Fi. Different type of technology are there for wireless. So depending on the application, like suppose you want starter speed terahertz. Okay, terabit per second. What kind of connectivity you want? Anyone know? For high speed data communication, what kind of connectivity can we use? Correct. There are like any technology like an for solutions. Yes, good. Which can use for high speed data. But that is for short distance, which is similar like Wi-Fi. Wi-Fi. Okay. For long distance, similar like airline, right? Fiber. Yes, fiber. But that is the wired one. Fiber is wired. Wireless one. Where is application of fiber? Yes. No, no, that one. That is all. Is test optic. That is application of fiber. You can translate signals to laser. Seven hundred miles. So we can translate data up to 700 miles. 700 miles is up to kilometer. 1 mile is 1.10. No, 1.6 kilometer. So that was distance you can cover. You can transmit data through laser. Okay. So in defense sector, so maybe India, Pakistan border, they use that kind of technology. Okay. But the only thing is there are some issues like line of sight. Suppose this is the signal classroom. And see now consider the same point. Now that is only one of it. High speed thing. There are when it goes in light speed. This also other relation between wavelength frequency and speed of light. Equal to nu lambda. Lambda is the light. So you can see what is the speed of light signal. So that way you can say that is you can say physical. So that is one thing. So there is lots of technologies are going on related to data network. Lots of people are doing. We are talking about 6G, right? Then 7G will be coming. What is 6G? 6G is all about this terahertz communication, right? Light speed. You want very high speed internet. This is 6G. People are this like this laser communication. How do you avoid this line of sight? People are doing lots of features. Okay. And here is a summarization of data networks. There are different technologies already I mentioned. Yes. So here there is FSO, 5G, FSO, NB-IoT, GSM, LTE, LoRa, everything is there. Then these are for short range communication, RFID, Bluetooth, Zigbee, Wi-Fi, Li-Fi. Okay. Then these are for long distance communication. These are for short distance communication. Then cloud. Just now I was explaining about some example, Amazon, AWS. These are different cloud services, but all are commercialized. You have to buy these cloud services. Okay. This no need to mention full process. These are different applications of IoT. Now IoT can be used anywhere. You can say if you add smart word, that is your life. Smart city, smart village, smart forest, right? So anything related to smart means IoT. See, this is the few application I have mentioned about related to smart city. It's like automatic traffic controller, accident detection, then crime detection, pollution monitoring, emergency vehicle management. These are all applications of IoT under smart city. So I'll be giving one case study related to accident detection. That's why I have highlighted. Okay. I have almost worked on all these areas. I have prototypes and patents on this. Using the architecture of smart city, you can see the architecture, including the cloud services. There are different type of applications. Even all the cloud diagram, very interesting. Like for the smart home, smart parking system, and then you can say the controller. Okay. Then you can say about criminal, what is the criminal one? Is it, criminal activity. There. This is a normal cloud architecture for smart city. Okay. This already I have mentioned about this, about the schematics of IoT diagram. These are the sensors will be connected to cloud, then cloud with this microcontroller, and this microcontroller will have different kind of connectivity technology like Wi-Fi. They are using MQTT, just now I mentioned MQTT or HTTP protocol. You can connect to cloud, and how to access cloud, and how to transmit data. That again you have to use different type of web interfacing software like using Python, Node-RED, Java. These are different type of programming language to which we can connect to internet. Okay. So this is the schematic diagram of IoT. And there are different type of protocols. Same like OSI 7 layer. That's in how many layers? 1, 2, 3, 4, 5, 6, 7. These are 7 layers of picture of IoT devices. Different layer like hardware devices they use these are the protocols. Okay. Hardware network layer they use Wi-Fi, Ethernet, 8, original 2.15.4 like that. Okay. And these are related to hardware platform. John knows about Arduino and uh, these are some of the specifications. It is a Hotmail 3 controller. This is another one. Raspberry Pi. Everyone knows about this. So it is like a small computer. Raspberry Pi is having Ethernet port, then LAN port, everything is there. Okay. Uh, so it can be used like a small laptop, small PDF. Okay. You can use for Python program inside this Raspberry Pi. Okay. But normally in Arduino, you cannot do Python programming inside Arduino. But in Python, in Raspberry Pi, you can do Python programming. Okay. But this is not for industrial, only for laboratory problems. These are very low-end devices, only for testing. This is another one. And there is some comparisons like for different companies, different ports, microcontroller ports, having different features like Wi-Fi, Ethernet, Bluetooth. So depending on this, if you have this table, no, like suppose when you are needing to develop some products, you should have this kind of table. You should know about what are the available uh, microcontrollers, different microcontrollers, what are the features, so that as per your requirement, you can choose one of these ports. Like suppose you want only Wi-Fi. So for Wi-Fi, the device is very cheaper. So, so you can use this one and this port, where it is current use. And you cannot use those ports because those ports they are not working on. But they have Bluetooth and some of the so they have Ethernet. So depending on your requirements, you can use it. These are different kind of sensors available in market, and some of the sensors are laboratory level, some of the sensors are industrial level. Suppose we are thinking about products, always buy industrial grade sensors and directly start working on. So that is expensive, but you'll be getting accurate results. Like suppose I have to measure the temperature. If I use industrial grade sensor, I can say the exact temperature of the sleep. But if I use laboratory level sensor, the temperature will be different. Then again, challenges already I have mentioned about challenges. Solutions that depends on you how you are going to solve those solutions. And this is very important. This stage, like when you are thinking about product development or any kind of implementation, these are the things you have to learn. And one person cannot learn all this. Okay. Because this any kind of product it needs interdisciplinary kind of uh, team. Someone should be from computer science, someone should be from mechanical, someone should be from industrial design, someone should be from electronics background, someone should be from maybe from ceramics or metallurgy. So you need different background of people to develop a product. You cannot develop alone. Okay. Because in software for software development, you can use many things. For any kind of product, these are the things you need to learn. Like Python, not there, Angular, not there, Android, those are for art. an ionic framework, database, like MySQL, CTL, MongoDB, Oracle, then Node-RED, Thread, ThinkTech, User. These are different type of software. Uh, you have to learn. Before you know, you have to learn. Some of the softwares are used for backend development. Some of the softwares are used for front-end development. Front-end means app. Backend means how you manage the database, cloud. There is that. And also in between cloud and front-end, like processing that part. So for that we need Python. Other Java also can use. C++ we can use. Those are things we need to learn. Then programming model. These are different programming models like nowadays people are using. Programming model means there are different libraries. The third party library you can use it like yellow. Nowadays people are talking about AI, artificial intelligence, right? Everywhere people are using AI, right? AI technique. They use these models, yellow, FSD, RTNN, W. These are few of them are open sources and few of them are commercial. Like for example, W. W is normally used in banking sector for prediction, broadcasting, anything like that. But we are very expensive. One license costs 715 lakh service. But so normally in academics they don't use it. In industry people they use that. But in academics people use yellow, green, and ASEAN. Those are common to say. Okay. Then coming to hardware devices. Hardware devices can see there are different types of microcontroller. You have to learn Arduino, Raspberry Pi, Node MCU, NVIDIA, ARM, Oral. These are the microcontrollers you have to learn. IoT. Then sensor is different types of sensors. Network devices, we have to learn about networking. Materials and layers. Like like a secret business. We have to learn many things. Like we have to learn Wi-Fi, ZigBee, LoRa, GSM, like TCP/IP networking, socket programming. How do you connect server on a device? You need socket programming. There are lots of programs. C, Java, Python, Visual Studio, .NET, C Hash, anything C can use. Okay. So one of the language you have to learn. Okay. Then technology related. Now these are different like of buzzwords like machine learning, deep learning, big data, edge computing, core computing, blockchain, computer something. Now let's see about thinking about blockchain. There are different types of technology. So technology means how you manage data. There was a challenge I mentioned right, data management. Technology means you have to use what kind of technology you can use to manage huge data. Okay. So blockchain. What is anyone know about what is blockchain? What is blockchain? What is the application of blockchain? Anyone knows? No, that is application of blockchain. But what is blockchain?
Blockchain is a server which manages the related server.
Yes, yes.
Data in a server.
Yes, different
So
server.
the one create some completely private, you can assign private or public.
Okay, you can use different server, but can you give some examples how different servers are used for some application? One application.
And servers.
Why they use different servers? Like for example, my name is Santosh Kumar Das, right? How many words are there? 3 words. Okay. So my name should be there in bank. I have bank account in SBI or ICICI or HDFC. They know my name, full name, right? They have their own server, right? But if they have 3 different servers, my name, last name Santosh, they can store in one server. Kumar, they can store in another server. That they can store in another. If some hacker, he is trying to access my information, we have to access all features. Okay, very good. Yeah, that is the purpose of blockchain. Okay, that's why nowadays lots of people are talking about blockchain, and they are using blockchain. This is for privacy protection. So, blockchain. So all these things you have to learn, and one person cannot learn. You need all this technology, all this programming language, all this concepts for product, any kind of product, mostly electronic related. Okay. So you need a team for product development.
What is big data technology?
Big data also similar like blockchain, but it needs huge knowledge base. So how do you handle those huge data? Like cancer data is huge data. So how do you manage those? But those are called big data.
Which small data works on the
So computing is actually it is something like edge computing. Edge computing is it attached to the device. Edge computing. Okay. Suppose you are working something in India, this higher cycle, which can process everything there, can take decision inside the time limit. That is called edge computing. Then top of that, there is a fog computing. Fog computing means you cannot process everything in that device. Some of the data we can store in different servers or different clouds. Small data we have servers. Okay. Then at the time of computations, you can actually store data. That is called fog. Then again the big data, top of that for something. Big data will be connection. We can use servers for bigger space. Just about problem. Then top of that, blockchain. So first S company, then for, then big data, then blockchain. That is the schematic. Now coming to case studies. Now these are the applications I have already worked on. Accident detection, price, heart attack, traffic controller, vehicle cost, then this is also there are some then life cycle for instance. Two extra I have worked on. Okay. I will come to accident detection. Here, the this is the animation I have given. What is the meaning of accident? Accident. So after accident, what happens? Now this information needs to be transmitted to the cloud. Then after that, there will be some processing and decision. So based on that decision, it will be calling ambulance, police, family member, friends, whichever you want to call. You can call. So that is called accident detection. This part actually I have implemented in that device. This is the block diagram. You can see that device. There's acceleration sensor, gyroscope, hydrogen sensor, arm sensor. These are different type of sensors used. It's only clearly sensor, not camera. Then there's this processor. I'm using the smoke and station. What? ESP30. ESP30. So I'm using ESP30. Okay. Instead of 49. Because ESP32 is having Wi-Fi module, unpaid Wi-Fi. That's why I'm using it. But programming is same. 49 is the that's difference. Okay. Then I'm using my own server. Like we have our own server, which is not related to Amazon or Google. This is the block diagram. Contain like sensor module, processing units, then decision. Then after that, the notebook. So notification means calling, ambulance, or sending message to family member, or email, either call, SMS, or email. These are the basic frequencies that for now. These are the prototypes. In the first, I just mentioned that initially we developed something because that was very bulky, right? We use the device. We are using now we have this device. We have a very battery, and the sensor, the many things are there. That's why it was very bulky. Okay. So we use different type of sensors. So then later on, we found one sensor which is giving all the Karyashala, gyroscope, windows, accelerometers, which everything is like perfect. That time is so it has it's the insult. And these are the insult value like sending message with the action alert with date, then longitude, uh, everything is there. Longitude, then Google Maps. If you click here, it will show you the location where the action is. And if you click on start something, you can go to the action. That's the purpose. And the email address you can send it and command click here and directly go to Google Maps. Then like this is another one. I'm just skipping after this. It's called crime detection. Any type of crime you can detect. Any type of crime. Murder, then fighting, whatever. Once detected, it is using the air computing device. That is NVIDIA. All processing will be there. So once it decides one type of it is here, then it is called the policy. So the purely camera based, and that is some kind of connection. And once the thing has been recognized, again the Google Map will become the location that you can be exact. So this kind of product can be used only by the police. Police. Here we have a 100%, and so we have that one. We have different type of crimes. Now we have 24 classes of crimes. We have to get. We have some related to crimes. Test. But the application already have tested. After application also says within some volume period you can inform to doctor. That is the yeah. This is traffic controller. So here actually the traffic controller means in normal side for when traffic what happens, they will put timer. So time and one traffic will go up, other one will go up. IoT. But here it will get on counting vehicles. If here more vehicles are there, this gate will go up. This lane will go up. Here only one vehicle are there, you have to wait. It is density based one. Density based traffic control. These are the five guidance and we develop the product. How are the time now? 1 hour over. Yes. You are practically ready. So it is pollution related with working on the pollution. I am just treating this. And this is high tech. Standard. So actually whatever usually we are using high tech standard. That's what percent. For high tech is not free. You have to pay for that. And we are thinking to replace it using MySQL or SQL. It is not possible. So these are database. And these are different type of neutral code based on our applications. Now, we have the okay. So I think one part I have completed. Then second part again I'm just going to the product part.
Which in IoT, but charity architecture is embedded cloud. Cloud is there for this embedded cloud is standard.
You can? No. Oh, this one.
It's embedded cloud. What is it? Cloud is embedded cloud.
Cloud. Embedded cloud. Embedded cloud means I mentioned about remote cloud, local cloud. Remote cloud is the local computer.
Can you share this slide? One of this.
Electronics. Okay, come to the into the electron. It's a metal system. Metal system using a law called IRIA, which is happened. These are the detail about the vehicle alert system. It only detects accident. This part. And gives alert message. Second one is it uses three different hardware devices. One is ESP32 microcontroller, then NPU 9250, and EPS module. These are the hardware devices. And it uses backend hardware database. Content it uses Flutter, and also we use Android apps. Either Flutter is for both iPhone user and other Android. But Android app is only for Android. Objective is only to detect accident and calling ambulance, family member, police, and fire. So these are the three different components. You can see that is MPU 9250. This one. And this is ESP32. That one is having all this functionality I just mentioned. And this is the GPS module. So these three modules we have integrated and developed this app. This is the app. Automated. This should be the driver app. The driver will be interface with automatically. Okay. So I will show you the demo after this. Then detection system basically you can say after collision it will just read all the information, acceleration, then and speed of vehicle, latitude, longitude, everything it will measure. Then it will transmit to the end users using files. And how do you calculate those parameters? I have mentioned over here. Like suppose I'm going like this. There is no sign. Again, also, it is a different time. I may go forward or I may go like scrolling or maybe rolling or maybe up and down. Not rolling, up and down. That is here, P and roll. So depending on those values, I can say that is accurate of it. There will be some kind of pressure. If it gets like 45 degrees, then you can say this accurate. So that kind of algorithm you can configure. And there is some application that they look. I mentioned here, mentioned here, gravity, that is 0.2 square. X I can mention here is X gravity. So my from that accent I will applicate the special that actually I have not mentioned over here. Simple that is related product. So based on that, so this is the these are few assumptions like that device we have taken some assumptions like suppose 10 gravity 10 meter per second that is actual accident. But for testing, for demo purposes, we make it high meter per second. And we make it translate then it's like that's for demo. So that was our mentioned we have mentioned for the demo. This is the flow chart diagram. The for action detection units. You can see that there is calibration for different type of sensors. Then there is a connecting to Wi-Fi connection. You need to connect to Wi-Fi connection. Then you need to collect GPS information. Then you need to decide whether it is accident or not. If accident, then you have to send information to database. Then if not accident, then you need to send the document. And these are the circuit diagram. Circuit diagram I have not listed. But this is the power file. It is designed with the production. That one is fabricated here. Inside the device, this is 32, then ion sensor, then and this is very simple factory. And these are pretty designing of the test. This is funny. That's why I just mentioned initially interdisciplinary type of thing. Like I'm electronics engineer, so I cannot design this one. I cannot design it. Who can design it? Okay. Industrial design or mechanical. They can design. So one defect actually they were working with me. You are the developers. Like where to put USB connection, LAN point, power supply, everything easy designs. Then we can in this product there is a content. So I'm going to backend part. In backend part, include the user authentication. So this is user authentication part. Then real-time database. Like Firebase, we use Firebase database. Then data handling between backend and frontend. SMS. Okay. So these are the backend functionalities. This is called SMS. Okay. So these are the 5 stages we have already implemented. Code wise, I'm just going to code now. See, first thing is in coding part, this is Arduino ID. First, you need to add, you need to import all these libraries. So, depending on your application, you might be knowing the Arduino programming language. So you can see, this is the console. I need MCU 925. So this meter file you need to add. Then only you can use that inside. Then Arduino.h. That is also header file into one. Wi-Fi.h. Because you are using Wi-Fi connection, you need to add their header file. That is the library. Right? Then suppose you are using Firebase, you need the header file. You need to add. Instead of this one, because you are using MySQL related library, you need to add. Okay. Then what is Firebase, then some other things like payload printing or something. You need to whatever the application you need to add those kind of things. Then only you can use the laptop. You know for importing library, then variables you have to declare any variable. Okay. So these are the variables I have used. Accident accepted, yao, key, zero. Because I'm using those yao, over and key. So that's why I have declared here. Initial value, previous value, then acceleration, what is operation, expressions, while then differences, then that's average acceleration, then start time. So these are the variables I have declared. Now Wi-Fi connection. This is the very important because on any device, suppose you want to make it a IoT device, how do you make it? Internet connectivity is very important. So very simple way how to connect to Wi-Fi. Because nowadays everyone is Wi-Fi connect, hotspot. From mobile also you can connect from sensor to your mobile. If you want your hotspot, it is connected to internet. So this is very important. See, I just mentioned Wi-Fi on installation. That is data. This means this is my hotspot, my mobile number. Okay. So I just mentioned this is hard coded. You can change it later. I have hard coded to my mobile number, data, and this is my password. 1, 2, 3, 4, 5. You can change. Either instance also, you can connect to any hotspot or any Wi-Fi. You can then how to connect internet? This is the process. Okay. Wi-Fi begin, then you have to access to its login ID password. Then it will begin connected to the Wi-Fi. Okay. So this way you can connect to Wi-Fi connection. Then after Wi-Fi connection, how do you connect Firebase? Firebase is database. This is another very important thing. How do you connect Firebase database or MySQL or SQL or connect? These are the steps. You need a TL. So you need the FCI or Firebase. Get your login function. I think you will be getting 1 month or 2 months free license. So they will be giving one API. So this is my API. Then database URL, that link also you will be getting from Google. This that I can provide. Then email ID, password is what is here and you set up you have email ID and password. This is the object you should clear. FTE. Target authentication, target function. So you have to do connect and there are many other opportunities how to collect, how to check email ID, how to connect, how to begin connection to these are predefined functionalities. Now, getting tax to run one program. Thank you. So these are the ways different tasks you can measure. There are 2 different tasks are there. Instead of you can get what kind of task you can do. One task is how do you read information from the server? Second one task can be. Second task is how to connect ideas. That means we have information how can do. The second task. Like that, you can explain what are the tasks you are going to do. Okay. Now, initially MQ and start calibration. That is using I2C protocol. I2C protocol. You can see this is a link given. So if you want to know about I2C protocol, you have to go to this tutorial. It is under random tutorial. And class HP32, which is original. With the I2C protocol, using this protocol, you can connect to. Because these are the things, and this address, the view address you can change. I don't know, I prefer to say you can change that. And you can collect. These are so these information from entry. These are you right. You can see the sensor panel. I'm using GPI of 22, GPI of 21 to connect to the entry message. So that we have to mention about card. Okay. Now this is about how you get NGO data and decide whether it is accepted or not. So these are the processes already there. Getting raw, these, those, then acceleration level, then upgrading the average level. Initially I mentioned the then it can implement it. And based on this value, can be accepted or now details data. How you collect details from the DHT windows. So you have to test to RSS. Yes, it's okay to check you connected to transmitter of detail. That is yes, transmitter check. Then you can program. Okay, this is for to get data. Now sending and receiving. So sending and receiving that of sending. You have to program like this. As because already you have connected to Firebase, only you need to check the target database, email, and that's a PD. If you just use mention about it, so it's not getting all the data. Now this is only like how we program using Arduino ID to access Firebase database. And then we can for you using MySQL. Because MySQL database is there. And you can suppose multiple number of tables. How do you access those tables? How do you update? How do you read and listen? There is some calculation table one. You have to program those. Send Firebase and program. Then consent. Those are otherwise batteries. So that ID. Now coming to content. This content you can design using any kind of language like I have used Flutter to Agile Android. It's Java programs. Now I'm using Flutter and I've given the application name is Trap. Then so these are the things. Now when you develop something at the beginning there are lots of what needs to be done. Because for Arduino itself, when you are programming using Arduino ID, one of the install video speed and what is the system configuration. We cannot install Arduino ID in all type of laptop or desktop. Give some kind of conflict. Similarly for content development. Suppose I am developing some apps using Android or Flutter. You need lots of software. So these are packaged. These are the things you have to download and install in the system. You need to install Android smartphone. You need to install Visual Studio. Both. These are all open source. But download and install. Next. You need to install Android Studio. You need to install. You need to have Google Maps as like smartphones. You have to update the number. And also you need to install IRIA. And lots of framework. Which you have to download and install. Now these are different software you need to download from internet. Then you need to install in the system. And your system will support all. You should have everything done. Okay. Otherwise it will not work. So better the configuration, better the implement. Otherwise it will vary. This system will vary. We need the higher type of project. Projects. This is a project we have designed for the after accident. iPhone is already connected to internet. In backend, I already mentioned file asset, how to share information file. So now my Firebase database is already having data. So I am accessing those information in my mobile and sending information to police, hospital, relative. Okay. And that time it will be giving some kind of information here, like maybe calling my family member and it will give some kind of information. Like 15 seconds. In 15 seconds, it will not cancel. Automatically, the family member will be listening to the call.
So it explains during that case, if the smartphone itself will damage and how it is.
Initially, it will sending message. For damage, before damage is just damage, no? It will be sending the message. Suppose damage conditions are there. So,
During accident only it can get crashed. Yes, then how it will send a message. If internal security is not working, in that
and initially it will be like that. But only suppose it was a concern, it will immediately it will send message.
only it was specific from the sensor device once it detects different thresholds. But in that case, not in that situation only.
Yes.
During the detection stage only it get damaged.
Damage, but it will be active for two.
Or it is such a solution until there's a question very fast learning cell phone
Maybe I don't know. Actually, nowadays what happened in big company, they have a class set. They will make next. They will pay. So this device will be accept. That's it. Then only you will be able to know that this is trap or you cannot send message. Then only you can see. Now we then only you can say whether it is possible or not. Testing only. Then now we are testing mild. But in mild accident it is happening. And we assume our device is like I mentioned now, it's a black box. In this casing we will get up, that is very simple one. We are replacing that one to a iron box. It will not spoil. That's all.
And one thing, after the accident, that message will give the other area. That is the one condition.
Yes.
So, what is the benefit? If it is accident is completed, after that it gives the message. So, what is the benefit of this situation?
What happens suppose I am going to some place and suddenly I felt some accident, serious accident.
So we have to test before the accident that when we give the information, it is better than that. No?
But, okay. So, what making? You should have accept the tension before accident. That is prediction. Again, prediction rate. It's very difficult to do predict. Only you can
We can also research the system that sensor can detect, before accidents. Like we are about to, accident, so it will automatically shut down the system and take emergency. Like already they are airbag is there. So we can also embed both.
that also you can
So which type of algorithm can be used in this area? There are two methods. If the data will be here available, you can use the application of the different algorithm. Other method is we collect the data by practically. So which types of this system we have available in this position?
camera data is different. Right? Then for that you need test data or that. But this one is what which real time data. It is not you any kind of passive. And the algorithm is not available. It's not. So we have to think about your algorithm. Right? You mentioned right. So you that before action is you can implement. You can think about that algorithm. So this algorithm it depends on you. What kind of like threshold I mentioned that.
So threshold will be developed in which can be different conditions. Different conditions have different thresholds.
Yes.
So that threshold be developed by the help of different types of data, or we have to use the some practical
Yes.
event.
Threshold one. Yeah. Threshold one. Only for threshold functions. Like high impact action, low impact action, and minor.
One minute, sir. Before this slot, you also discuss about the 45-degree threshold,
Yes.
right? If the object motion is high, naturally degree of the system be increases.
Yes.
And it is balanced. Last day we visit in the telco, there have some testing of the track that will move in this direction. This is not a 45 degree. It is here about the parallel of the system. That is the direction. So how can it be balanced if we give the idea about the 45-degree threshold?
No, it's 45 threshold. It is only to say whether accident happens or not. Because some vehicle they don't provide that 100% that it will be
Right. If the road is that this direction, so this is near about 45 degree, and the object will move and in this position. Like 45 degree.
direction also. Acceleration, x axis, y axis, z axis.
So it is balanced by x, y, z axis. That is the one thing.
So this is the plot diagram for front-end design. Then these are in the application algorithm we develop. I'm not going to explain that one. Very time is over. Then these are the front-end design. These are the session. These are like login, reset password, actually button mentioning, signing button, then emergency alert, art minimum and first line, operating information. You can see all this already developed. Welcome. Then this is 90. These are the password. This is the signing button. You can cancel or go. Cancel means there is no call, no message. That means driver is there. Signing contract. And we need the interface indicator. Then we have the Google Map. And we have some results so we have taken like when I'm driving with the road condition. It will be giving some normal driving scenario. If you have some guiding role, future and role. Now, uneven road, you can see positive value in gravity. Of course, you can calculate as an iron purpose you have for right. You have a purpose. You have a purpose. And different detail. Now, if you want to see some demo, you can go there.
Batch of 6 students can come.
So,
Sir, in this, if we are going from like Rourkela to Jamshedpur, sir. So we are just, near to Jamshedpur. So as you said that we have to add the emergency contact number.
Yes.
Okay. So is there any system that it will automatically dial 102 that nearest police station?
You can mention multiple number of emergency. 1, 2, 3, 4.
And sir, before sending message, is it warning something or so
Yeah,
that
it is giving kind of 15 seconds or something that depends.
only message display message or sir, some sound like
Yes, only.
so that we can also stop that
Yes.
message to be sent to the forward. Very good, sir. Very good.
any queries like anything you want to ask? Sir? Yeah, I think so. We'll be having a practical sessions too. Something related to they'll be making the groups and all. So before that, just as a token of gesture, we want to just give something first to sir. I would like to call Rishi Kumar Jha sir, who is also the participant of this workshop. So please honor sir with a gamcha. This jargon we use and memento. And a small gift for you.
Yes, sir.
Useful for our students. Thank you, sir. So we'll be welcoming Harshit Srivastava, sir, who is just about to be doctor. He's writing his thesis. So please be interactive so that you can learn much in very short span of time. Okay, welcome. Please.
I will be calling 6 students, so everyone will be able to do and perform that. So in real time, we will be doing everything. So I want to come in a batch of 6. I think there are 18 to 20 students. There are 18 to 20 students. So within 3 to 4 batch, we can complete, and everyone will be having an hands-on session, right? So participants, please come.
Six from this side, one by one, we can get the opportunity. 1, 2, 3, 4, 5, 6. Please. तो उसके चक्कर में सीधी नहीं पाऊंगा. Sorry for that, sir. We left one thing more for you, sir, as a token of gesture. I'd like to call Harshit, the president of team Innoreva of IIT Jamshedpur, to please gift sir with a token of faith. Actually, the answer is busy in India. So much. आपका सबके लिए अपने से इंटरेस्ट बोले हाँ बरोबर है वो आपके लिए बैटर गैस आउट वाली ऑफिशियल यूज है ये कोडिंग विद कोड्स